find out how speed is different from velocity. Speed is the rate at which an object covers distance. It is a scalar quantity that describes how fast an object is moving. Mathematically, we say v is equal to x over t, where x is distance with an SI unit of meters. T is time measured in seconds, and v will be our speed, which will be in meters per second. Most of the time, what we measure is the average speed, which is the total distance over the total time. On the other hand, velocity is a vector quantity that refers to the rate at which an object changes its position. Instead of distance, we will be using displacement. And since velocity is a vector quantity, it requires direction, which will come from its displacement. So for us to be able to solve speed and velocity problems, I am expecting that you know the differences between distance and displacement, as well as how to find for resultant vectors. Let's start with this boy who walked 10 meters to the east in 5 seconds. The average speed would be 2 meters per second if you use our speed formula. And the velocity will be 2 meters per second to the east if we use our velocity formula. The only difference here is the direction, since we use the displacement 10 meters to the east for our velocity. So you might ask, are the magnitudes of speed and velocity always equal except for the direction? The answer of course is no. You see, if after walking 10 meters to the east, the boy went back 4 meters to the west in 2 seconds, the average speed would be the total distance, which is 10 meters plus 4 meters, over the total time, which is 5 seconds plus 2 seconds. The average speed will then be 2 meters per second. How about the velocity? Since we need the displacement for us to solve for the velocity, we need to find out the resultant vector of our figure. The resultant vector of this problem is the distance from the starting point to the ending point of the boy's motion. The resultant vector, by the way, represents the displacement. The displacement here will be 6 meters. We divide that by the total time, giving us a velocity of 0.86 meters to the east. Again, I am assuming that you know how to find for the resultant vector. In this case, the motion of the boy is considered one-dimensional because all vectors lie on a straight line. Now, if you need to review how to add vectors in one dimension, watch this video, which is also available in the description below. Now, what if the motion is like this? The boy traveled 10 meters east for 5 seconds and climbed 5 meters north for 2 seconds. What will be the speed and the velocity? The total distance will be 10 meters plus 5 meters, and the total time will be 5 seconds plus 2 seconds. So, the average speed will be 2.14 meters per second. How about the velocity? What will be the displacement? The shortest distance from the starting point to the ending point will be the displacement as well as the resultant vector. We can use the Pythagorean theorem to solve for the magnitude of the displacement, since the two vectors form 90 degrees when combining them head to tail. The magnitude will be 11.18 meters. And how about the direction? I will be using tangent function, which is tangent theta is equal to the absolute value of the ratio between the opposite side of the angle and the adjacent side of the angle. The angle will be 26.57 degrees. These two vectors are considered two-dimensional because it involved two axes. And again, I am expecting that by now, you know how to add vectors in 2 dimensions. If not, then go and watch this video, which is also available in the description below. After finding the displacement, then solving for the velocity will be a piece of cake. But let's challenge ourselves with this kind of problem. What if our energetic boy traveled 10 meters to the east, 5 meters 40 degrees north of east, 6 meters north, and 7 meters 30 degrees north of west? The total time for the entire motion of the boy is 50 seconds. Perhaps the easiest to find is the average speed, which will be 0.56 meters per second after dividing the total distance over the total time. Now for the velocity, if you will solve for the displacement, which is the distance from the starting point to the end point, you will get that is a very long solution, but I know that by now, this should be an easy job for you. If you want to see how to solve for the displacement, then watch this video as a review as well. After finding the displacement, then solving for the velocity will be an easy job for you. I hope that you were able to differentiate speed from velocity. Keep solving and I'll see you again next time.